All right. Yeah, so I called it Enablers for Scaling Robotaxis Globally. However, it will touch quite a few topics from regulation, from technology, from business models, and so on. And then please feel free to ask questions or save your questions for later, for after the presentation, whatever you prefer. I'm fine both ways. Maybe one note. There is this is intended for this masterclass, right? We really want to have a good discussion and so on. If you have any requests or any other questions around the slide deck or additional material, or you want to share it further, please don't hesitate to reach out to me. I would appreciate that, so that I and my company also knows where it's going. Now, one thing is some of the things are topics that may not necessarily present all of Pony's opinion, but I think that's quite normal. But I try to be as broad and as open as possible, so please note that for me. Cool. Maybe very briefly about Pony. We've been founded in Fremont in California 8.5 years ago, and grew from there really fast into China and to in California as well. We were actually the first one to provide a public-facing robotaxi service with a safety driver back then, but still in Irvine in California from 2019 to 2021. And now we are really working a lot on robotaxis, robotrucking, the personally owned vehicle business units. We have about 1,400 people. And since 2022, things have become really exciting. We started our driverless services, commercial services, now in the four Chinese tier 1 cities, so Beijing, Guangzhou, Shenzhen, and Shanghai. And we also started driverless trucking and platooning last year. So all of the things are coming together now, and the technology development has been quite remarkable, and also the integration with partners. Since November, we are publicly traded at NASDAQ, and we also started operating in Luxembourg, which maybe for many of you from Europe is very interesting. We have our headquarters there. We have partners there, and we actually do road testing. I was there for the last 2 weeks, and yeah, we're making good progress as well. So what's really exciting and where we are in this transition phase now from doing a lot of R&D, enabling the technology, we're now in the phase where we work with 3 OEM partners in China: Toyota, BAIC, and GAC. BAIC is the Beijing Auto Innovation Company, and GAC is the Guangzhou Auto Company. Toyota, you should know. We really work on mass production right now. So we're not talking about retrofitting in dedicated facilities. We really talk about having manufacturing lines for these vehicles with, as you can see, very reduced sensing stacks to only what is really necessary, to a very low price point. And these vehicles have been, if you got a chance to go to Auto Shanghai about 2 or 3 weeks ago, you could see these vehicles in person, and they will be on the road during this year in much larger quantities than these retrofit concepts we have used so far. Let's start a little bit about our business perspectives and the current challenges or kind of like developments that we have on the business side. Now, I'm always trying to observe a little bit what's happening globally and which markets are really interesting. And we see certainly that in China, the number of fleets that are commercially used are growing pretty quickly. It's not only Pony, it's actually quite a few companies that bring robotaxis and shuttles, buses, trucks, and other things to the road. By the end of this year, this should easily be more than 5,000 vehicles. And this is more than the rest of the world combined. So China is really moving fast on these topics. But also in the USA, especially Waymo is deploying a lot more vehicles. When you are in San Francisco, it's kind of the go-to mode of transportation. The growing ODDs also in Phoenix, Los Angeles, Austin, Atlanta, and many other places make it a service that is quite consistent and really good usable. And at least this year, we believe Waymo and some of the other players that are still in the US will grow to around 2,500 vehicles in commercial service. But Europe, of course, is a little less. The focus is less on robotaxis. It's actually more, as we just heard from Oliver, actually, on there's logistics applications, there's public transport, there is closed area applications like in airports and so on. But overall, we believe that the number is a little smaller. And then there are the other regions of the world. Now, why is it so important to have vehicles? One of the key things that we see is the availability of data to train and tune AI models that actually drive these cars. And data has been scarce in the past, and only a few companies have really, well, maybe enough, or at least a lot of data that can be used to build AI models that generalize very well to many driving environments. And so the more vehicles are in the field, the larger is the data pool that becomes available, and the better those systems become. So if you already have lots of vehicles in the market, for example, if a single company has like 1,000 or 2,000 vehicles in the market, they are collecting a lot of very, very interesting data, not only from general driving, but also from edge and rare cases. And this is really the secret sauce to build a very, very robust AI stack. And if you only have like a handful of vehicles, it's very unlikely that you are able to collect the same amount of data and therefore build the same safe and performance system. So scaling these fleets is crucial. And I've worked at a lot of companies, starting in research projects in Germany, but then later at Zoox and Didi and Pony. And you could see the difference in the available data amount in the performance of the AI stacks. And that's also why Waymo is so good today, and definitely by far the market leader in the US, because they started early and they focused on having large fleets very early in the market. So that's one of the key differentiators that we see globally, where we believe China and the US have definitely an advantage over the rest of the world. Now, how does this look like today? So this is one of our operational videos here from Guangzhou. You can see it, and it comes through nicely. So yeah, so basically, what we and other companies are currently focusing on is really about how can you now, well, the technology is at least solved for specific operational design domains. How can you scale this, and how can you make operations as efficient as possible to really provide services to a lot of customers? And as you can imagine, in China, the four large cities together have around 1.5 million taxis and ride-hailing vehicles, which is quite a large market that we can address. And now it's really about how can we scale this quickly, and how can we build unit economic positive vehicles that can be deployed there. I think there was a question in the chat. Let me see if I can find it.
Yeah, but shall we take the question at the end of the presentation, maybe, instead of stopping the? I don't know what you prefer, Andreas, but maybe we can go over that after you finish.
We can also do it in the end, yeah, if we collect it there.
Okay, it'd be easier, I guess. Yeah.
Okay, perfect. So based on this goal of scaling, what are companies focusing on? And it's pretty clear that the largest players currently are focusing on the robotaxi use case, just because the business model is so interesting that when you can build a single vehicle and the unit economics are right, and you can essentially scale into a market that already has 1.5 million ride-hailing vehicles, like, you don't really have to look at other applications to find ways to make a lot of money. And for us and for Waymo and maybe for others as well, this robotaxi market is really the interesting piece. where the outlook for investors is much bigger. The outlook for high revenue, high profits is much bigger than, for example, in the shuttle market or for larger buses. However, of course, not every, and that's really an interesting thing when you scale globally. Not every city and every region is built in the same way. Some have amazing infrastructure for public transport. Others basically have no infrastructure for public transport, which I would count the San Francisco Bay Area, at least to a large extent, into that. And so many applications make a lot of sense. However, and this is really important, many of the companies like us are still in a phase where we are in this transition from a scale-up to becoming a high revenue, high profit company. And so the focus on the most interesting business models is extremely important to survive in this market. Many companies were not able to do that. They either ran out of money or ran into other issues. And so for us, this focus on robotaxis, of course, we do a lot of other things too, but the focus is really on the robotaxi use cases. And there on essentially 3 topics. One is how can we build the vehicles as cheap as possible, which we currently achieve with existing mass-produced vehicles that are then built slightly different and become robotaxis. And this is what we do with our partners. It's not a retrofit where the vehicle is first built and then our tech is retrofitted, but it's also not a purpose-built vehicle. It's somewhere in between, which is currently the cheapest way to actually move forward. For this, partnerships are incredibly important with OEMs, with tier 1 suppliers, and with other manufacturing and operational partners. And the last piece is, and I'll go into this a bit more later, is the technology generalization, where we want to grow from ODD sizes of maybe just a few hundred square kilometers per city to basically the city boundaries, or even more, even outside of the city, to airports and train stations and so on. And for this, the technology has to advance a little bit more so that the costs for new deployments can be reduced. Okay. So one of the enablers, and kind of to summarize this a little bit here, is really the business model. For startups and scale-ups like us, it's focus, and really figuring out what we can do. What we have seen is it's a lot easier when you have products in the market that can, for example, compete with ride-hailing, that you can have dynamic pricing. You can have usually lower costs than human-driven vehicles. In our case, we were able to lower our insurance costs to a level way below a human driver, because we have much less insurance claims in our ODDs already. So at that point, we can be very competitive. And yes, we're sorry for the drivers, but essentially we're building a product that's more efficient and more reliable and provides a more consistent service than human drivers can have. One thing that we noticed outside of the US and outside of China is kind of interesting. There are a lot of discussions around how this technology should be used. And the whole AV industry is targeted from various angles. And I'm sure Oliver and Xavier, you have a lot of experience there as well, and many of you too, because you may be from public transport operators, or you may be from a taxi company, or maybe you're from a ride-hailing company, or maybe you started from a completely different angle in this topic. But overall, we see that everyone is trying to find out how this technology fits best in their current operating model and in their current business model. However, what we see is the technical capabilities are actually all very similar. And the end product could actually look very, very similar. Maybe it varies a little bit in the number of seats that you have, from a very smaller one with only 2 seats all the way to a robotaxi with maybe 7 or 8 seats. But in the end, the technology and the effort you need to take to bring these up is more or less the same. And this development is quite interesting, at least from our point of view as a technology company, because we get approached from all directions. And everyone is kind of asking for the same thing from different industries. And sometimes for us, it's not easy to navigate what is kind of like the winning use case. I used an example here because I've used this vehicle personally once from the Karlsruher Verkehrsverbund. This is not an autonomous vehicle, but it's actually a human-driven shuttle vehicle that is added to public transport. And these are everywhere. Yeah, the on-demand shuttles, or Anrufsammeltaxi in Germany, or Rufbus in Luxembourg, or whatever it is. And this is, of course, exactly the same for us as a robotaxi. Like, there's no difference. So the question is always like, are these just intermediate products that are currently there, but in a couple of years will be replaced by a full robotaxi, or where is this development going? So a very, very interesting thing. What we have seen in China and the US is once the robotaxi services are deployed and people can experience the consistent service, it's their preferred mode of transportation. Absolutely. Like everyone prefers using a robotaxi in which you have privacy, you feel safe, and you can do essentially work or be on the phone or whatever without anyone listening, including a driver, and you have the space for yourself. And so if you can afford it, this is the key mode of transportation that's currently being pursued in China and the US, and we'll see if that's different in Europe in the future, I guess. I talked briefly about partnerships. Now, in order to bring many of these vehicles to the road, it requires quite a few things. There are existing transport network companies, the TNCs, there are vehicle manufacturers, there are technology companies that approach the problem differently. But in the end, everyone is kind of working towards the same. The TNCs and others are working on providing good service. The manufacturers want to sell as many vehicles as possible and have as much after sales as possible for maintenance and other things. And technology companies want to implement their virtual driver licenses or technologies. Now, there are only very, very few companies, if at all, that do all of these things. I can only think of Zoox at this point, in the US at least, that is really able to build a full vehicle, wants to establish a ride-hailing service and tackle the market, and has developed all of the technologies in-house. But of course, that's very expensive. We're talking two-digit billions of dollars that have to be spent for that. It may make sense to actually move into partnerships, and we see a lot of those partnerships forming. In our case, here's an example from Luxembourg. We partnered with Emil Weber, a transport company there that runs taxis, that runs buses, that runs a lot of other services to the public. And these collaborations enable us to understand the market, to understand the needs, and to understand how our vehicles will, or how our technology in the future will be best used. In the specific case, there is Emil Weber was so kind to provide us space in one of their depots where we can house our vehicles and start from there data collection, testing activities with currently still with safety drivers, not yet driverless, but of course that's on our roadmap. The use cases are very, very interesting. So Emil Weber runs about 300 taxis in Luxembourg, so there's clearly a taxi use case. But they also run a lot of small and larger buses to transport people in the city, but also from the surroundings of the city, from smaller villages, smaller communities, to larger public transport hubs. And we will work with them on all three use cases to find out which ones are best for the technology, what we have to change, and how customers will use this in the future. And we hope that very soon our vehicles will be ready to provide also demos to interested parties, and eventually lead to of course free of charge, but service on selected areas or selected routes or so that we get also feedback from a lot of the customers very soon. So far, this has been a great partnership, and for us, the first step in Europe, also to tackle regulatory landscapes and many other things there. Very good. So I've talked a lot about business models and partnerships and so on. This only works if the technology is really ready. And I want to show you a quick example here of, this is a video from Guangzhou. And we've been operating in Guangzhou for, I think, 6 years now. And it's very interesting to us because Guangzhou is subtropical climate. So if you have been there, you will see it can rain pretty heavily, pretty surprisingly fast, and then stop raining again. And this sorry, I'll stop the sound here. This gives us a chance to, from the beginning on, to develop our technology not only for nice weather, but also for good weather in very challenging situations. Here you see a typical day. This is not even rush hour or anything. This is just between 6 a.m. and then 10 p.m. This is the kind of traffic you would find there. This video, by the way, was shot in 2022. So it's one of our first driverless rides in the city. And as you can see, this is something where maybe even humans that are not familiar with the environment would struggle a lot while driving. The particular challenges there are lots and lots of agents around us that we need to perceive, and a very competitive driving environment. So it's not about being nice to each other or anything like that. It's really very competitive, using every centimeter of the road. But from our point of view, the technology has been ready about 3 years ago to actually operate in such environments. And now it's really one of the challenges is that we can scale this into new ODDs. And this is something that has taken not only us, but also other companies quite some time. When you think of the first driverless deployment, for example, from Waymo, which was, I think, in 2020 in Phoenix, it took them more than 2 years to deploy in the next city. And then it took them another almost 2 years to deploy in the next city, so kind of from San Francisco to Los Angeles. But you can now see a trend that it's actually going much faster. They're testing in Austin, for example, took them less than a year to go into driverless. Atlanta is already on their roadmap, and a couple of other places. And it's very similar for us. So over the past years, it has been quite challenging to really transfer the technology to a new operational design domain, to new driving culture, new traffic rules, and many other things. However, we see that this generalization of driving stacks is now reduced to just a few months to go from one city to another. And that's why I'm very positive of also adapting our technology, for example, to European traffic. Because you have other traffic rules, you have definitely a different traffic culture in many regions of Europe, like people in the Nordics, in the UK, in the central part of Europe and in southern part of Europe. They all drive differently. And it always takes us a couple of minutes as a human, or maybe even an hour or two, to really adjust and see how traffic works. However, I think for most companies, or all of the AV companies, they don't do online learning in the vehicle. So they first have to collect data, go back to their desks, basically retrain their models, adjust to the environment, and then test again. And this iterative cycle takes much longer than a human would have to, or than a human could adapt to different traffic cultures. And so this has been quite expensive still, because all these testing activities, all the computing power that's necessary to retrain models, to run simulations, the fleet operations, and so on, this has been quite costly in the past. But we really see the trend now of this becoming cheaper, becoming more affordable, and scaling can actually move faster than it has been in the past, at least for I would say for the leading companies worldwide. And what's also kind of interesting is that you can use a lot of the same software modules now across regions. So for example, for environment perception, there is not really a challenge, a different challenge in Europe. Maybe there's a certain traffic sign that looks a little bit different, but fundamentally the models are the same. People look the same, cars look the same, trucks and houses look the same. So from that perspective, it's actually becoming more and more of a generalized unified stack. But on the planning and prediction side of the stack, you still see differences, because you have to adjust to the local regions. Cool. Another thing that we at least have been pursuing for quite some time, and other companies are also now getting more and more into, is the reduction of cost. It's very unlikely that a vehicle that costs you 250,000 euros to actually be put into operation, so including the vehicle platform, including the retrofitting and the sensing, the computers and so on that you add, that such a vehicle can be profitable over its lifetime. That's actually quite hard to achieve. And so it's very important to get these vehicles to a much cheaper level. And not only Pony, but also I think Apollo, Didi, and some other Chinese companies have introduced their mass production vehicles, and they all claim a reduction of something around 70% from the last generation. A lot of this comes from the fact that LiDAR, 4D imaging radar, high resolution HDR cameras, and so on, are getting much, much cheaper and become commodities because they are integrated into level 2 vehicles. So basically into personally owned vehicles. And suddenly you have hundreds of thousands of units, maybe even millions of units produced per year. And it's just natural that prices drop significantly. So a couple of years back, everyone was saying, oh, LiDAR is way too expensive. We need to deploy without LiDAR. We can't afford these sensors. But today, when you buy a LiDAR that we integrate into our vehicles, you pay less than $1,000 for a unit. For next year, those prices are supposed to go down to $500 per unit. So suddenly you can build a stack that's probably around somewhere around $10,000 to $20,000, including the computers, all the sensors, all the wiring, HMI, anything you need to put into a vehicle to make it a robotaxi. For less than $20,000, in the future, likely less than $10,000. So at that point, it actually becomes a product that is cheap enough for any taxi application in any market around the world. You always have to remember that in China, transportation is multiple factors cheaper than in the US or in Europe. So, which means when you can make it unit economic positive in China, these vehicles will be highly profitable in other markets of the world. And this is really the goal that we try to achieve and that many others try to achieve right now. Now, another thing, there was also something, computing power was kind of an issue. You had to go with x86 chips, so basically server-grade CPUs and server-grade GPUs to run your systems. I think some of the largest companies still run server-grade GPUs as their computers in the cars. Now, this is, of course, not automotive standard, and this is way too inefficient in terms of energy, but also in terms of cost. And NVIDIA has really made a difference there with their Orin generation. We believe that 1,000 TOPS of AI inference computing power in the vehicle is actually sufficient. You can achieve that today with 4 of the Orin chips. Now, Thor will come, is actually already being tested, which is kind of the successor of Orin. And it provides all of this computing power in one chip that you need. So the computing problem is kind of solved for us, at least from a manufacturer like NVIDIA. And so we see all of these things now coming together where the sensing prices go down. They are high quality. They are high functional safety standards up to ASIL B integrity, if that's something you're familiar with. The computing power is cheap enough. The cooling, the networking in the car, and so on are ready. The software modules generalize more and more. So we really see this phase now where things are coming together nicely, and scaling is finally becoming the big topic for the industry. How this looks for us and many others is maybe a bit more in this video. So you can see the industrial design and the integration of the sensing is much, much more subtle than it is in existing vehicles. Everything integrates really nicely into the body and a small rack on the roof. And that also makes it, since it's all integrated in manufacturing lines, it makes it much, much cheaper. Very good. So this was a little bit about business perspective and remaining challenges. So really, the robotaxi business model seems to be the most viable right now. So many companies focus on that. And then there is the aspects of technology generalization and bringing the cost down. Now, this is kind of like building a product. However, this product needs a market that allows the product, which is the regulatory side, and it needs to be safe. So I want to briefly look into these two things, and then summarize the presentation a bit, and then jump into your questions and hopefully a good discussion. So I think you're all familiar with regulations, with bureaucracy, and so on. And we've looked into many, many countries. And I'm not talking about Europe here alone. I'm talking really about worldwide deployments in the Middle East, in Southeast Asia, in Central Asia, in South America, in Northern America, and of course Europe as well. And many countries are still really debating about this technology. Some have more focus on let's say, transport unions who don't really want this technology killing jobs. Others are concerned about safety. Others are concerned about privacy and security. But very few countries really enabled the technology so far in a way that it works together with how autonomous driving companies work and how the business models can work. But overall, I would say that there is the possibility to test with safety drivers in many places. You can even, in some countries, deploy with safety drivers and go into a commercial service. Yeah, and then take the next step to actually test safety drivers in very small volumes and then deploy in very small volumes. However, one of the things that's kind of like a common question is, how do large-scale deployment requirements really look like for deploying lots of vehicles in a commercial sense? Because it's not only about safety regulations and automotive regulations, it's about the commercial aspect. It's about taxi concessions. It's about who's actually allowed to transport people in which regions during which time. So this has become quite a complex environment. And everyone is willing to solve these problems, but definitely at a different speed and a different approach. And so I've summarized a little bit what we experienced in countries like Korea, Singapore, China, the US, also in discussions with the Middle East, what their commitments are in various countries. And some of the really good things that work for us is having dedicated contact persons for an ODD and for a company from the regulator. So really people that you can just call and give them a question. I think California has been at the forefront of that a little bit, and I think Miguel Acosta was here a couple of weeks back. Like he was really the key person in California to establish these things and make it work for companies and have someone that you can just call. And if you have any questions or you have an idea what could be changed or so, you have personal contact. It's very easy to access and very responsive. And so that's the second point where, for example, in California, the regulators guarantee you a 30-day response time on any requests you have. That sounds quite long because that's like 4 weeks in a couple of days, but this is much faster than many other regulators can act. In China, this is probably less than a week. If you have a question there, you get an almost immediate response, and you have someone who can help you solve your problem as a company, which is a very, very interesting environment, because the regulators are really seen as enablers in a sense that they monitor what is happening with the companies and in traffic. They synchronize usually very regularly with companies, and they provide support if there are roadblocks in the regulations that don't make sense. So it's not like we put one regulation out there and then autonomous vehicles can be deployed. It's actually a very iterative process with very short regulatory cycles. They're almost working like a development company that tries out various things and iterates really fast. And this is something, especially in China, but also in some other countries, where we see a lot more motion and a lot more speed in regulations really getting where they should be for the whole industry. And it includes the public, it includes the regulators themselves, it includes, for example, insurance companies, transport providers, technology providers, and so on and so on. So much, much faster regulatory cycles. What also is happening is they, at least in China, but also to a large extent in the US, they try to avoid scattered regulatory landscapes. Because if a city, a county, a state, a country, and a region has some say, there will be lobbyist groups, there will be lots of others talking into this regulatory topic. And that creates a lot of usually friction, a lot of delays, and a lot of uncertainty in the end. And so what we've seen in many countries is just reducing uncertainty about how regulations will look like, increased transparency about why certain things are regulated in a certain way, and seeing flexibility with regulators has been quite important for us. Now, not saying things in Europe are bad or anything, it's just a different regulatory approach than in the rest of the world. But from some countries, we have seen things that are considered blockers rather than enablers. And that's not how regulations should be at this point. So that's really one of the challenges. And also one of the things why companies are looking more towards the Middle East, to Asia, or the USA to deploy their vehicles first, because there's a lot less uncertainty about these regulatory topics. So enabling efficient and effective regulations, I would say, is one of the key things. And yeah, strict detailed regulations are actually not an enabler, because it's really hard to say today how the final regulations we will have in 5 to 10 years will actually look like. This has to be an evolutionary process, and in our opinion, and also from my experience, it's kind of interesting. About more than 15 years ago, I was at a university, 16 years ago, and we had the first testing vehicle in Germany ready for level 4 technology as a university in Braunschweig. And nobody knew what are the requirements to actually bring this to public traffic and test this vehicle with a safety driver. And so back then, we worked together with the technical service and local regulators, and it took us about 6 weeks to get a permit. It cost us a couple of hundreds of euros. Sure, we were a university, maybe it was a little cheaper, but it took us about 6 weeks to get an official permit that we can test this vehicle in public traffic in Germany, in the city of Braunschweig. I recently spoke to a professor at a conference who has been in the field for about the same time as I have. And he said if he would want to do this today in Germany, it would probably take him 6 months, and he would pay thousands and thousands of dollars if he's even able to do that. And so things actually have developed into the wrong direction. And just one anecdotal example of how important it is to enable efficient and effective regulations that don't overshoot their goals, that don't make too many assumptions about what could happen or how it should look like, because nobody really knows, or at least people just start now to understand how these regulatory things can play out in the future and should look like. This is just the basic principle that we kind of combined what is happening around the world. So you start essentially here on the left for an autonomous vehicle permit with 2 or 1 safety drivers, depending on where you are. You need 2 or 1. Then you can move to a safety co-driver, kind of, who has only brake access. This is actually something I've not seen too much in Europe, but it's certainly something that has been done in the US and in China. Then you move into only an attendant in the car, so no controls access, so basically not able to do anything in the vehicle. And that's where companies consider it being driverless. Now, this step I wouldn't call driverless, because there's still someone monitoring the brakes and interfering at some point. Then at some point, you go into remote operations only, so no attendant in the vehicle, usually 1-to-1. And then later into remote operator to vehicle ratios of larger than 1 vehicle per operator. Some companies in China have permits already for 1 operator to 15 vehicles. So the technology has advanced so much, and when you look closely in the video I've shown you in the beginning, in this particular case, in this ODD, I think there were 10 vehicles on the screen of a remote operator there. Now, the purpose of these things is clear, like really iterating and moving fast to go into driverless operations. And especially the last one is highly iterative. Like the more you drive and the higher your mileage between collisions or other unwanted events is, the more vehicles per remote operator you can essentially do. And then next to that is the service and commercial use part. So in the beginning, it's no third party allowed. Then members of the public as passengers are allowed in trial or free of charge. And then later a service of pair charging. And what we have observed, what's really beneficial for companies, is that even in the first step, when you do AV testing with a safety driver or 2 safety drivers, you can have a paid service. Because at that point, it becomes a model that people get used to, that people really understand what this technology can do in the future and have exposure and can give feedback and feel like they are involved in the deployment of this new technology to the market. And this is really the best thing that happened in the US, but also in China, that very early customers could actually experience this technology instead of waiting until it's really 100% ready and in operations there. Cool. Yeah, that kind of plays into the social acceptance piece. As you may know, in China and also in the US, the public wasn't asked if they want to have robotaxis without drivers, right? It was just tried out, and surprise, what happened is people were happy with the technology. Many prefer having no driver in their cars, in their taxis already, because of the consistent service that they can provide. So the question is really, is there a social acceptance problem, or is this just a discussion that can be where more data is necessary to really move forward? And so I believe having more deployments and having more exposure to people to the technology is one of the biggest steps forward to enable. Well, you don't have to enable social acceptance. Actually, a group from Europe visited us a couple of months ago, and they tested Waymo vehicles in San Francisco. There were like 10 people, and everyone was driving for more than 5 hours, and really tested the service. And then they told us they have to rethink their strategy. Maybe this robotaxi use case is actually what people want and what is best, and maybe we should focus on how can we make this affordable to the public, other than trying to find out how we can reduce a large bus line to 3 shuttles. It was really interesting conversation, and really this exposure to the technology can move the needle a lot towards better, safer, more secure and more private ways of transportation that have a huge, a very, very large consistency over each ride, because each ride is basically the same. Like when a Waymo makes a mistake somewhere on the same day, you take the same Waymo, you go to the same location, it will make the same mistake. Of course, they are consistent on their faults too, but overall on the ride quality and everything, we believe that this is a very important aspect, and we see this in China a lot. We have more than 70% recurring users that actually commute with our vehicles already. And that's exactly what we believe people should be able to. Nobody needs to force them to use our robotaxis. In large Chinese cities, you have a lot of public transport, but a lot of people actually want to use it. And so we see it as an advantage. All right, I have one last topic to talk about, and then we can go into a short summary and discussions, which is safety. And you have Phil Koopman in a couple of weeks. I think he's the best one to talk about safety for autonomous driving, for sure, by far. But I at least want to explain what I've observed from Pony, but also other companies, what's really focused on in safety. So one of the key things is, and that's basically from a regulatory point of view, the absence of unreasonable risk when operating a robotaxi or a L4 system in public traffic. There's a huge debate of what unreasonable risk is, and I don't think we need to do this today, but maybe you can ask Phil Koopman. He will certainly have a very, very good explanation. And the other part is we want to have compliance with current and future regulations so that the safety approach can actually work not only in one region, but can work globally. And this is really the key thing. These requirements are very different across different countries. You have type approval in Europe, you have self-certification in the US, you have kind of a hybrid of that in China, and it's getting more and more towards the type approval direction. But overall, these are very, very different challenges. The Middle East is catching up a little bit and tries to replicate what Europe is doing. So quite an interesting landscape. And so we brought down these 4 topics: statistical evidence, standards and processes, long-tail events and edge cases, and human factors into, we call it the 4 pillars of our safety framework. And this is something that's more or less the same across the industry. So you have a lot of driving, a lot of simulation, a lot of testing with safety drivers until your system is really ready to be deployed driverless. And that's all done with a lot of statistics. The key metrics are there: how many collisions per mile, or how many miles between collision, however you want to measure it, or kilometer are there. How many near misses, how many unpredictable events that your car did so that others reacted oddly to you, how many harsh braking and harsh swerving maneuvers, and many other metrics that you can measure in simulation, that you can measure in the field, and that you can evaluate very precisely. Now here the big challenge is, and the big question is, how safe is safe enough? And again, Phil Koopman wrote a whole book about this question. I can only recommend reading that, because it gives you a lot of variables, a lot of insights on how this could be defined. Now, in essentially, when you read Waymo's safety publications for the US, this is the statistical part, that they have 83% less airbag deployments or 81% less reported accidents per kilometer or per mile than a human has. So this is the statistical part. In China, this is embedded in regulations. You actually have to show a certain distance of driving in an ODD without any of these unwanted events before you're allowed to take the next step. For example, moving the driver to the co-driver seat or to the attendant spot or out of the vehicle. So this is very much defined in detail, and it allows us to iterate together with the regulators on the safety piece. However, of course, statistics is not everything. There exists for good reasons existing standards and processes around, for example, safety management systems, functional safety, safety of the attendant functionality. There's a lot of cybersecurity aspects. And these things have to be considered and have to be integrated into development and test processes, and then result in configuration management, verification plans. A lot of the foundational work that comes from the automotive industry has to be considered. However, formally, it only has to be considered in Europe. Like in the US or in China, you don't really have to have that many standards that you really have to show and work with a technical service on that you comply to these. And that makes deployments, of course, faster. Now, many say, well, that makes it more unsafe. However, I would question that. Having seen the US market with Waymo, having seen what we do in China, I don't believe there's a huge difference. And so the question really becomes is how relevant are these standards? Because many of them were designed for cars that are sold to customers and then have those vehicles over a lifetime of 12 years and can do whatever they want with these. Whereas robotaxis are more like service vehicles that are professionally maintained, that operate in very limited environment conditions, at least for now. And the whole operation is monitored by a professional company. So it's more similar to an aircraft model or to a bus model for public transport or a train model. And so there are a lot of questions around which standards should apply and to which extent to this technology. And it will certainly be interesting when the first type approvals for Europe may come by the end of 2026 or maybe in 2027, what exactly the requirements are that the companies have to meet. Both of these statistical evidence and standards and processes mention long-tail events and edge cases quite frequently. So these are really the events that you probably experience yourself less than once per year or once per 10,000 kilometers. This could be a very tricky piece of, I don't know, metal lying on a freeway, or it could be a very weird jaywalker, completely black dressed, walking around in the rain in a dark intersection. Right? These are things you don't see every day. These are pretty rare, and collecting this data has, at least in the past, been hard when you only had 10, 20, 30 vehicles. But now with fleets of hundreds that operate 24/7, you can actually collect a lot of these rare events. And then the other part is these edge cases, how we call them, is when you basically want to find out what are the limits of my vehicle's capabilities. For example, like what is the lowest latency at which, or the lowest reaction time in an accident situation I need to avoid an accident, and what can I no longer avoid. So really understanding what are the boundaries of your system, which are usually done in dedicated testing, dedicated data collection, and there are large databases growing every day, especially with companies that have huge road operations, and then transferred into simulations and tested. And the last thing that we've been looking for quite a lot, and a lot of learnings went into our latest designs, and I'm sure others are doing the same, is, one is, of course, driver monitoring, safety operator testing. But once you have no operator anymore, people do a lot of stuff in those vehicles that they would not do when there would be a driver. Although there are usually interior cameras and other things, but people are just open to doing a lot more crazy things, like driving on a freeway in a driverless car that still has a steering wheel and trying to grab the steering wheel at like 100 kilometers per hour. Like, who would do that, right? It's not very smart. But you have to prepare for this misuse, and you have to prepare for really good passenger interactions and so on. And you have to expect the weirdest things happening, which in our case, we've seen a lot of stuff, and we were able to design our systems so that many of these things can be prevented. And there will be a lot of additional things that are going to happen in the future for sure. One prominent example where it was not from the interior but from the exterior was people putting traffic cones on the hoods of Waymo vehicles in San Francisco. Yeah, when you hear it, it's kind of funny, but it can actually cause a lot of trouble, right? And this is just misuse, and you have to be prepared to tackle this. One key thing that we have seen is you have to have field response teams as an autonomous driving company. So you really need humans that can be at any vehicle in a given amount of time, maybe within 5 to 10 minutes, because there is so much stuff that can happen to these vehicles where it's just not possible to use remote assistance to free up the vehicles. All right, just a glimpse into safety, and Phil Koopman will tell you a lot more about this topic. So just summarizing here, we talked a bit about business models and how robotaxis are currently, for many companies, the most interesting one, just because of revenue and profits. Partnerships are extremely important between OEMs, demand companies like transport network companies and others, and technology companies, because as far as I know, basically no OEM has internally, without any partners, the technology to actually deploy driverless vehicles in robotaxis. Generalization is important to reduce the cost for enabling new ODDs. Hardware is on the right track, so it's really about software and how quickly you can run these vehicles in a new ODD now. There is regulations. Iterative approaches are much preferred. Less uncertainty is always better, but you cannot require the same level of safety if you want to deploy 5 vehicles compared to 5,000 vehicles. These are two different things. Social acceptance, I think, is always getting higher when end users are more involved. So don't wait for the permission to test vehicles. Just do it and then invite people to try it. And then lastly, on the safety framework side, I think, having been in this industry for quite some time, it is understood what you need to do, but it is a lot of work, and it's really a question if companies are willing and ready to execute on these safety frameworks and really bring everything to the market. Very good. And with that, I'll leave it at an outlook, and then we can talk about specific questions in a second. I believe we're finally at the point where in 5 to 10 years, and this is kind of like a running insider gag in the industry, it's always 5 to 10 years, right? Until a lot of cities will see robotaxis, more than 20 in the USA, more than 20 in China, and more than 20 in the rest of the world. And when I say robotaxis or shuttles, I mean large volumes, like not 5 or 10 or 20. I'm talking about thousands of vehicles at this point. The personally owned vehicle market will catch up. We didn't talk about that a lot, but L4 in freeway driving will be available by 2030, so 5 years from now. And in another 5 years later, personally owned vehicles will also enable L4 in probably 90% of the driving distance countrywide. So really, when driving around on many roads, I think L4 will be available in personally owned vehicles as well. Hardware and software will be commodities, so hardware will be less than $10,000 per vehicles in 5 years from now. Pretty sure about that because we have seen contracts already coming together for sensing equipment, for computing equipment, and so on. So there will be more and more companies have that technology. The differentiators will be brand and reputation, with, I believe, safety as the key factor. Like, the companies that will be considered safe will remain in the market, and you cannot really allow yourself too many safety problems, because then customers will lose trust in you. And the second most interesting one, and that's something we observed in China a lot, is the ride waiting time. Like, if you open your app and you want to get a taxi or ride hailing or whatever, or you want to compare it to public transport, it's really all about how long you have to wait. It's not so much how long your ride takes, actually. It's kind of interesting. It's really about, do I have to wait 5 or 10 minutes? Oh, it's 10 minutes with a robotaxi. Well, then I take a human-driven car because it's only 5 minutes. And that's something we have observed a lot already, and interesting development. Now, when it comes to safety benchmarks, kind of the last point, when you look at Waymo's publications from the recent weeks, comparing AVs to human drivers is the right approach, in my opinion. But human drivers with driver assistance systems will actually raise the bar constantly. And you can already see that Europe is multiple factors safer in terms of road traffic than the US, which is multiple factors safer than China. That's just the reality right now. And so when you use the human drivers as safety benchmarks, deploying in Europe is much, much harder than it is in the US, and in the US is much, much harder than deploying in China. I think that's something we can all agree on just because of this particular metric. Very cool. And with that, yeah, thank you for listening. And please reach out also after the chat if you have any other further questions. And I'll stop sharing now and we can get into a discussion at this point.
Thanks a lot, Andreas. It was brilliant. Really, I think, I mean, we learned quite a lot of things. So I'd like Oliver to contribute for the discussion. I guess there are a lot of questions that will come. Maybe we'll first take the few questions that we have in the chat. Benjamin talked about, maybe you can have the question as well, Andreas. It's going to be easier if you can open the chat. So if you see the first reaction of Benjamin and then Simon, and then we'll move forward, and afterwards we can open the queue. So Andreas told me he could spend maybe 10 to 15 minutes more than what has been planned. So we have plenty of time for discussion. And anyway, the session is recorded. So if you need to leave, you can see the end of the conversation afterwards when we will publish it on some channels. So yes, Andreas, maybe if you can take Benjamin, and Oliver, do not hesitate to interact as well.
Yeah. I think I'll read the question quickly. I'm not sure if everyone is reading on the chat, but I'll just read it out loud once and then we can talk about it. So you have clearly outlined the importance of data quantity as in many vehicles on the road. Having worked with, an example, Cruise, or especially Cruise in the past, where this was an issue, what is your take on data quality? Specifically, the ability to process these enormous amounts of data to find and work on the relevant edge cases to develop the ODD into the right areas. Well, that is actually the key question on data right now. So this is pretty much on point. Collecting a lot of data is really important. But then really figuring out which data should be used for training is highly interesting. And we have seen a couple of things in the industry and also for ourselves there. So first of all, you need really good data filtering, right? Because it's so much data that you cannot store everything. You need good retention policies and so on. But this is something that naturally grows in the company. So a lot of data, for example, when you have low counts of agents and basically nothing happening around you, you just ignore it. Or what you could do is you could have algorithms that compare your, for example, stored data sets in terms of scenarios, test cases, and so on, to the new data and figure out what the delta is according to many variables. So really trying to find out, is there in the new data that I just collected, are there any gaps that I can close in my existing data sets? So that's another thing that we are doing a lot to reduce the amount of data we have to store. However, there's an interesting observation where different companies and different approaches provide you with different challenges. For example, we have seen and we've tried ourselves a lot of these end-to-end learning approaches by observing human drivers. So if you do that, you will not get better than a human driver. Because when you only observe what the average human driver, because in the end it's the average human driver, what they are doing, you will not get better than that. So what we've seen is data collection is important, the filtering is important, but then you need to use this data and create really the hard cases that your system needs to solve. And those hard cases you usually don't observe a lot, even when you look at human driving data. And that's why we are very skeptical if companies, and I'll name Tesla here, for example, say that they observe human driving data and then train their models on exactly that. Because when you drive a Tesla with FSD, and I've done that for 1.5 years now, probably around 15,000 miles, you see exactly the mistakes that humans make, also done by the car, right? And this is something that we learned, that the industry has learned. So what you have to do is you collect a lot of data, you have to filter this data and see which gaps it fills in your approach, but then you take the scenarios that you typically create from this data and build out more challenging variations of these scenarios in your simulation environment. And that's really the key thing, how to build a driver that is actually better than the human driving data that you observe. And that's really the key thing. Now, when it comes to edge cases for this, you will actually create your own edge cases by doing that. Because if you use this adversarial testing in existing scenarios, you will create the cases in which your system can no longer solve it, right? You will get at the performance limitations of your system. And this is something we've seen maybe over the last 2 years, 1 to 2 years, as being a trend in many companies of using existing data as seeds and then creating the really challenging stuff. There are quite some publications from Stanford's Safety for AI Center, most prominently called adaptive stress testing. It's a technology that comes from the aerospace world and is used in autonomous vehicles as well. I hope that answered the question.
Yes, I think it did.
Thank you.
Very good. So next one from Simon. Do you think your robotaxi fits for shared use? I mean about booking, intimacy, potential conflict between two users, because that vehicle could be a kind of mini shuttle with a lot of potential in Europe. So
more about software and operation than hardware.
Yeah. I understand. So generally, nothing is preventing us from doing that, right? We have algorithms that allow ride pooling, shared rides, and so on. What we have seen, though, Didi in China and also Uber in the US have implemented their own pooling offers. I think it's used by less than 2% of all customers. So the question is this worth an effort? And that's something we know probably not as good as we should at this point when looking at the European market. Now, we've seen when we ask our riders what they really why they are using us and not other services with the driver and so on. They mention privacy. They mention they don't have to deal with other people, and they mention that they can do whatever they want and feel not observed or listened to by any others. And so when just listening to that, I think it makes a lot of sense. However, of course, from an operational point of view, technology point of view, you could put, I don't know, take the Toyota BZ4X. It has 4 adult seats. When you ignore the driver's seat, you could put 4 different people into this car. But even with Uber vehicles, people were not too familiar to do this. People did not get really into this because, first of all, your driving time is a little more unpredictable. Second, the cost saving is usually not that big. And third is, in an Uber driver, you still have the driver who can be a moderator if there are problems with other riders, which you don't have in a robotaxi. So there are benefits of that. There are concerns. I think it's something you just have to try out and really figure out, like, how does the public respond, and what the sweet spot is also in price savings that people would accept for that.
Great, thank you. And do you think that the Zoox approach is a bit, it's a bit specific because it looks like people are looking at each other and they've made a design that's very particular.
It works in trains and buses, and people get used to that. So that's why I think it is a viable approach. Again, it's something to try. I have a sense that it's regional, very, very different. Right? Could be that in certain cities people are open to it. In other cities they don't really want to do that. I do believe it is a good idea because, of course, you want to have more than 1 or 2 people in these vehicles when driving around, and make them more effective in terms of reducing congestion and reducing number of cars and so on. But yeah, it's something to try out. It's very important to design it properly. Giving people enough space, maybe give them the opportunity to control their own climate, right? Because that's something that's different in a car than in a bus. The bus has some sort of climate and some temperature and so on. People get used to it. But in a car, it can be very particular that someone wants to have 23 degrees Celsius, another person 19, right? How do you solve that problem? Or do you have to deal with the average? Or what is about infotainment and music? A lot of our customers actually use Bluetooth functions and can use infotainment via the car audio and don't have to wear headphones, right? That could be an advantage, especially when you're on longer travels and things like that. So if it's designed in a nice way that you can still have a little bit of your own private space, I think it's fine, but we'll see. When you look directly into the eyes of somebody else, it may be a little different because the seating distance in a Zoox is also smaller than in a subway or in a bus in many cases. So it's a little more intimate that you get with fellow riders.
Great. So Dario had a lot of questions. Maybe you can pick one
Yes,
of Darius'
well,
questions.
it's three bullet points, but quite short actually. So maybe the first one, I want to know whether there is a difference between the American and Chinese ADS system between the stack. I know maybe some specific training for each part of the ocean, and then we can go on the next ones afterwards.
Yeah. So on the hardware side, they are the same. There is no differences in sensing, computers, or anything. The vehicles we use are different in our case, but it's just because of the markets. On the software side, there are differences. Not so much in the perception piece or localization or mapping or how all of that works. It's mostly about the planning and, the prediction and the planning algorithms. So we use both AI-based and rule-based algorithms in both of these. And you have to fine-tune for different markets. Even in the beginning, we had different prediction and planning tuning in between the Chinese cities, but now we've generalized that part. For the US, it is different because you have to adapt to the traffic rules, and those are usually the rule-based, hard-coded to some extent. And you have to adapt to the driving culture, especially the assertiveness of driving maneuvers. One example is lane changing and merging. Right, those things are very, very different in China than they are in the US. So you have to fine tune that you behave like the locals would. So I think that's the key difference. On the perception side, I think I said earlier, it's the same. Like cars, people, whatever, it all looks the same. There may be different variations of traffic signs and traffic lights, but other than that, it's very simple.
That's not the main point, of course. Okay,
yeah.
Thanks. I'll go quickly to the other question I had. So you mentioned collaboration with big OEMs now, so Toyota, BAIC, and GAC. You said that those weren't retrofitted vehicles. Does it mean you have like specific production lines at each one of those facilities?
So it's not from the ground up a different production line, because some parts of the vehicles, actually large parts like the chassis and other things, are exactly the same, the batteries, drivetrain, these things. So they are manufactured just like they did it before, but then the line splits. One direction goes into the human-driven variant and another direction goes into the autonomous variant, where modifications are made or different harnesses installed, different cooling, different power supplies. The sensing is different. Interior differences. It's more like a taxi interior rather than like the more premium interior you would get for a human-driven vehicle. And then, of course, in the exterior where the sensors are integrated, there are different stations. So it's kind of like a large part, I would say 85% are probably the same, and then it splits up into two different directions.
Okay. Makes sense. Thank you. And
which, by the way, this is actually a great question regarding cost. Like, we have looked into many models, including purpose-built vehicles and so on. But at least today, we see this as by far the cheapest approach to produce large quantities. Even taking a vehicle and retrofitting it is far more expensive than doing that, even if you have a facility. So there is a huge cost advantage on doing it. And we believe, since this is done by our partners who are professional automotive manufacturing companies, the quality will be much higher. That comes out of that.
You are no car designer or car OEM, so I think it makes sense to kind of keep your own job in this case. And then last question. So you were mentioning ODD and the way that it's expanding. Are there like specific points you are working on regarding expansion of the ODD that you didn't foresee beforehand and that you face today and that you have to work on to expand this ODD?
I think there have been over the last 2 years, there has been a focus on freeway driving and really enabling freeways. So what we have accomplished now is connecting places like airports to other centralized points in the city. This could be hotel districts, financial districts. This could be train stations or large public transport hubs and things like that. So driving on freeways has been quite important, and it actually required us to modify our sensing stack a little bit, because you need longer ranges. We believe you always need 3 modalities: LiDAR, vision, and radar. And for freeway driving, cameras can detect small obstacles somewhat reliably on the surface, but not perfectly. Radar usually is pretty bad on small obstacles. So we had to add a LiDAR sensor that has a longer range and higher resolution specifically for freeway driving to be able to drive up to think it's 120 kilometers per hour. So at that point, this has been one of the ODD expansions that we've been working on. The other one is improving pickup and drop-off locations. That's really one of the key things right now for robotaxis, because you may have seen that in the Guangzhou video, but next to the road are usually these barriers, and then there's bicycle lanes or sidewalks. You're not allowed to stop anywhere there. So you have to figure out what is the closest place to the address that the customer wants to, and how can you stop there, because sometimes customers need a little more time to get out of the vehicle. Maybe the next customers directly go in. So you will be standing there maybe a minute or two. And without creating too much of a disruption to traffic, finding these right pickup and drop-off locations is more and more a focus point. And also, you don't want your customers have to walk 200, 300, 500 meters after you drop them off, especially not in Guangzhou when it's heavily raining. So this is one of the things where allowing this almost fully dynamic pickup drop-off in the ODD is very important, and designing that has been a key topic. But other than that, in terms of traffic rules or environments or weather, we drive at night, we drive in any rain and wind and sandstorm and whatever you have in these cities.
Yeah, the goal of the question was to see in the end where the limits still are. So you kind of answered to those questions. So yeah, thank you.
Yeah, I mean, electric vehicles have a disadvantage, right? You have to stay close to your depot. So doing really long distance things is certainly something that we will be working on in terms of limits. But other than that, no, it's fine. There is it's going in the right direction. And if you come to Silicon Valley, I can only recommend you take Waymos for your next city tour and not the big red buses, because you will learn a lot where the limits are pretty quickly.
We'll do it again for sure.
Great. Maybe we can take two things. James and Bezad as same kind of questions. So, what are the next steps for Pony in Europe? And then Bezad is, insisting on the fact that it could lead to increased car usage. So maybe you can answer to that. Future developments, and also how do you consider that you could increase traffic?
Yeah. Okay. So there are a couple of things there. So we for our European efforts, maybe we start at that point. We have planned. So for now, this is an exploratory phase, right? Really getting started and getting comfortable with the regulators. The next steps, of course, will always be to expand the ODDs, to bring more vehicles, and to build partnerships. That's the key thing. We believe that the market in Europe will be different. We will not show up as the next ride-hailing company in Europe. That's very unlikely, at least from our point of view, where we stand today. It's more useful to partner with more, maybe even public transport providers or taxi companies or others outside of that. And then from there, we will see where the opportunities are and where the markets are. Of course, we have a tendency to go into larger cities first, because that more vehicles will be needed in those larger cities. But there may be an interesting case of having automated on-demand shuttles somewhere. Not shuttles as a shuttle vehicle, but maybe it's still a passenger car, but use these vehicles as shuttles is one of the topics that we look for the European side of things. Can you help me with the second part of your question, how you summarized it? Sorry.
Do you foresee the impact on traffic and congestions and so on? Because it's kind of private trips that you will provide.
Yeah. I personally have always believed that there will be mixed traffic going forward, and people will not drop all of their cars just because you have robotaxis around. And at some point, your personal car will actually be the robotaxi for you. Well, I'm quite sure this is going to happen, right? We're currently at level 3, and at some point we will go into level 4. So from that perspective, I think looking at what ride-hailing companies have caused in terms of traffic is a good example that there may be a phase in which you will see even more vehicles on the road first, but then over time there may be the opportunity to reduce vehicles on the road. but it is highly dependent on where you are. If you have, like most European cities, if you have a really, really strong public transport system with trams, with buses, with other things, I do believe that the technology has less of an impact into overall traffic volume at this point. I really see that shuttle buses and other buses will actually improve the service and extend it further out from the city centers, and in parallel tackle the problems of like driver shortage and other things that currently exist. I don't think there will be a huge impact on the number of cars you will actually see on the road, at least not in, and it's really hard to tell. In other areas where you have basically much less public transport, I could see that it will help. I can really see that when you have a reliable service, people start doing things in Los Angeles. I read an interesting article about they use Waymos to now bring their kids to their soccer trainings and other things instead of driving themselves, right? They leave their cars at home and let the Waymos do that, because in the past, they didn't really want the kids being in Uber vehicles with a driver they don't know, right, with a random person. But now, since there's nobody in there, people trust this technology more. So I could see that the number of short distance drives in cities where public transport is not so much available will actually go down, because the vehicle utilization of these robo-taxis will be much higher than any personally owned vehicles. But it's really hard. It's a really tough question, and I've seen models going in both directions. so I don't know what's going to happen actually.
Okay, thank you for the transparency on that. So maybe 3 more questions in the chat. Tamaj is talking about do vehicles talk to each other somehow, and will they able to talk to other operators as well? So kind of a centralized system.
Yeah. So what? So they don't negotiate driving behaviors or anything like that. But of course, we have centralized fleet management and know where all of the vehicles are. And through this fleet management, the vehicles can share information about the environment with other vehicles. For example, if a lane is blocked because of a construction site and the vehicle encounters this for the first time, this information can be used to update the maps for all the vehicles in that same ODD and basically say, avoid this area. Or they can provide information about traffic density when you have, I don't know, maybe you have a collision or something that's causing a blockage, that's causing a traffic jam. This information can be shared, but not on the tactical driving level that they coordinate anything. We don't do that, but really informing about events that have been seen in the environment that require or could lead to a more optimized behavior of other vehicles driving around.
Great, thank you. Tim is asking a bit about robo trucks. What's actually difference between robo taxis and robo trucks, and how do you see the potential of this? And I think Oliver was a bit was asking the same kind of things when we exchanged on the questions.
Yeah. So the logistics and especially the trucking businesses are definitely interesting for this technology. However, there are certain differences again between markets. For example, in China, people can have rest time in the cabin of a moving truck, meaning that when you have 2 or 3 drivers in a truck, they can essentially drive 22 hours per day with that truck. So there, one use case is not necessarily to remove all the drivers, but to reduce the number of drivers in the vehicle so that maybe only one person is left. That's already a huge cost savings for logistics companies. So that's one case where it's not fully driverless, or it's more like a system where the truck does most of the stuff, but then can ask the driver for help to get them out of a tricky situation or something. So that would be the very much the long haul trucking. So really long routes, maybe even multiple thousands of kilometers from start to finish and so on, where no rail is available. This case seems to be interesting because it's basically all freeway driving, and you still have a person on board for the really hard stuff of the freeway, like going to the depot or going to the final location. So that's a very interesting case. Another one is where you have hub-to-hub transport, like Aurora, for example, did like 2 weeks ago. So when they started their driverless operation, this is kind of a no-brainer when you can really do that because you can suddenly, and especially in the US, I think driving time is limited to 11 hours max, like in certain circumstances. You can enable longer routes than that. So you could, for example, have a route that's, I don't know, 1,500 miles long, and you just let an autonomous truck do that for you. So this is also very interesting. And then you have these recurring routes where you have shorter distances, maybe you have 200-300 miles, and you do it 5 times per day. Like, that's really annoying for drivers. That can also be done. So there is a lot of applications in long haul trucking when you go from depot to depot. And if you're able to basically, once someone helped you, or I'm speaking of the perspective of the autonomous truck now, someone helped you getting the trailer on and everything ready, and then you drive to the destination, you park somewhere, and then a human takes over. This can be very interesting. So these are applications that we see a lot. And the last one is we're finally at a point where convoy driving or platoon driving is enabled, and not only from us but from other companies too. So, for example, you are at a construction site and you have dump trucks, and they all need to go to the same location. You just build a train of 5 trucks, and then you drive there. This is something we've tested successfully, and we have actually deployed to a coal mine / power plant site where the coal is transported in trucks. And so now you have one driver at the front, and you have empty trucks following. So this is also something where our technology could work. So there are quite a lot of applications that make a lot of sense. But compared to the revenue you can create on robotaxis, it's still smaller. It's not small in a sense that it's not a good business, but it's smaller than what we believe robotaxis can do in the future.
Great. And then we have a last question from Alessio. So I don't know, Andreas, if you see it in the chat.
Yes, I can see it.
Yes.
When it comes to safety within EU and UK, have you collected data showing some EU countries not being that far from US actually, and others having the bar really high? So for that question in the beginning, yes, we have looked at all countries in the world at this point. And we have seen that, I think, I may be wrong, maybe there's 1 or 2 countries in Europe that are close to the US, but all other countries are safer when it comes to collisions per vehicle miles traveled, especially on fatalities, major injuries, and minor injuries. The US still has a lot more fatalities. I think last year was 45,000. Compared to the vehicle miles traveled, this is a worse safety record than Europe. There may be individual countries, 1 or 2, that are somewhere on the same level. But for example, when you look at the Nordics, or when you look at the UK, France, Germany, Spain, Italy, those countries are definitely safer than or of course, Netherlands and Belgium and so on, and Luxembourg and Switzerland and Austria. Those are safer in terms of traffic records than the other countries. I can only recommend, by the way, we are very much AI-driven company, so we also use a lot of AI. Like, try to get access to a good deep research model and put exactly your question in there. You will get a fantastic report. And that is actually very accurate, we found. So a lot of the work that we had to do manually in the past, a lot of AI models are now doing for us, which is certainly a shift in how we work. And regarding to traffic statistics, there's so much material out there that you get a really clear picture of what is happening in these countries. Now, of course, should we go first to countries that have a worse traffic record? That's an interesting question. I could imagine that there will be European regulations at some point that try to unify the level of safety you need to have. And actually, there are already some that unify the level of safety you need to have to deploy autonomous driving. So not sure if this is a good path forward. But it's something to think about, right? If there are markets in which traffic safety is a huge problem, the technology can of course provide a safety advantage. Yeah. Okay.
Maybe we can take the last question from Kun, which is maybe a good ending point.
Yeah, of course.
If you see it, Andreas.
Is $1 per mile or 60 to 70 cents per kilometer as TCO for robotaxi realistic in 10 to 15 years? So with the operating costs that we have to achieve in China, I would say it will not take that long. because in China, actually paying 60 to 70 cents per kilometer is already upper limit of what you pay for a ride-hailing vehicle. In rush hour you pay more in certain locations, but on average that's about where we need to be. So we believe that our now built generation of robotaxis will be unit economic positive, which means we have to achieve something like that. Now, of course, China has lower wages for remote operators, maintenance staff, and so on and so on. So there may be a little more work to do, but if we ignore inflation in the next 10, 15 years, I think we can actually get to the point where $1 per mile is feasible. And that is, of course, highly competitive compared to other modes of transportation.
Yep.
It is.
Thank you very much.
Thank you so much. So I think we could discuss this for a much longer time. Maybe I'd like to ask Oliver to make like the main conclusion. And already I'd like to thank you, Andreas, for the great presentation and being so transparent in the questions as well.
Yeah, thank you again, Andreas. I think it was an amazing presentation. We learned a lot. I think you also helped to paint a very positive picture of what autonomous vehicle technology could look like in the future, not only in China and the US, but also in Europe. I think barriers will open up, regulatory barriers, safety barriers, acceptance barriers. And I think at the end of the day, it's just a question of time. And soon, hopefully, we will be able to see automated vehicles that will, and this is really what we hope, that will be implemented for the greater good. And for this reason, we really, I think in Europe, we really have this opportunity to integrate public transport with autonomous vehicles, to create this combination between autonomous vehicles and public transport. I think could be the future of this compromise between private vehicles in AVs and shared vehicles in public transport. Simply integrating both modes might be the best compromise. So maybe that's an interesting closing word. And I'd also like to thank Xavier and Dario for this really good organization and this fascinating webinar.
Great. So thank you. Thank you for staying online. So we'll try to publish it on the YouTube channel as soon as we can. If you've missed or if you'd like to share it with some others. So Andreas, great. Thank you. We wish you a great day in the Bay Area. We'll go and sleep now. No, not exactly. But next webinar with Phil Koopman in 2 weeks. Do not hesitate to register and feel free to contact us if you have any questions, if we can help you support your activities. And we keep in touch in the great world of autonomous mobility. And talk to you soon. Bye-bye.